Okay, I'm back. I lost track of time. I wasn't paying attention to my time because I can only do these videos in 15-minute increments and I wasn't paying attention. And so I'm just gonna do one of these, and I was gonna do the one that looks like it's a parallelogram so that you could see all the justification you would have to show. If it's not a parallelogram, you just have to show that one of the sides, that one of the pair of opposite sides is not parallel. As soon as you find one that's not parallel, you show me the two slopes, you say not parallel, and then you say can't be a parallelogram because it has to be two pairs of opposite parallel sides. And once you find one pair of opposite sides that are not parallel, then you're done. It's not a parallelogram. But let me show you the work that goes into showing it is. So then this was like our example where you would count rise over run. I'm going to do slope because that's a lot faster. You could use distance formula and try and prove the opposite sides are congruent. It's just a lot of work. You'd have to find distance formula here, distance formula here, distance formula here, distance formula here, show that opposite sides have the same side length. That's way too much work. Just count rise over run to show that the sides are parallel because we know parallel lines have the same slope. So I'm going to count from A to D, so I would go up 2, 1, 2, 3, 4, 5 to the right. So the slope from A to D is 2 over 5. Slope of its opposite side, BC, we'll go from B to C up 2, 1, 2, 3, 4, 5, so it's still positive 2/5. Okay, and so these are parallel, so I know that segment AD is parallel to segment BC. So I'm going to put those arrows there. Now let's do the slope of AB. So I'm going to go down 1, right 2, so that's negative 1/2. And the slope of DC, so from D to C, down 1, right 2, so that's negative 1/2. So then that shows that segment AB is parallel to segment DC. So I'm going to put double arrows there in my picture. And so yes, it's a parallelogram. And your justification is the work that you did to show that. Okay? So that's the easiest way in a coordinate plane to show that you have a parallelogram is to prove that you have opposite parallel sides. Because then you just have to do slope and you can easily count rise over run and not have to do distance formula. Okay? So then again, you'll have some good coordinate geometry on the EOC, also on the Chapter 8 test that you'll take on Thursday. Okay? All right, so go ahead and put everything away, close everything up, just have a pencil out. Do not need a calculator for this quiz. All this quiz is quizzing your, do you know the 5 ways to prove that a quadrilateral is a parallelogram? There is a front and a back to the quiz. You are only going to do the front at this time. You're only going to do the front of the quiz at this time. So when it gets passed out, you're only doing 1 through 3 on the front. 4 and 5 we will do at a later time on the back. Okay, so you're only doing 1 through 3 on the front. Okay. So go ahead and pause and take your quiz at this time. You should really only take you anywhere from 5 to 8 minutes to do these 3 problems. All right, so we finished with example 2 in your notes yesterday. So if you haven't already, take out your notes and open up to where you had set up your 8.3, 8.4 notes. We're gonna finish those notes today. So we'll do section 8.4. And then you'll have time to work on your homework and do your Cornell note repetitions. We'll do 8.5 in a recording tomorrow, just in its entirety, so that I'm not having to split up the section 8.5. So we left off on here. You should have done that problem. And so now we're going to go to proving, once I know something's a parallelogram, can I go further and then prove that it's also a rectangle? Because remember in that hierarchy I showed you guys somewhere right here. Okay, so you've got quadrilaterals as like the big kahuna, right? Any 4-sided figure falls in the quadrilateral umbrella. The ones that we've talked about so far is this branch here, which is parallelograms. Rectangles, rhombuses, and squares are all parallelograms because they're underneath that, okay? And every square is a rectangle, and every square is also a rhombus because it has part of its definition is the definitions of these two pieces. Okay, and so that's why this is all kind of arranged the way that it is because parallelograms are like the granddad of all these guys, because rectangle, rhombuses, and squares are all parallelograms. And then you've got rectangles and rhombuses. Squares are also rectangles and rhombuses. So remember that squares have all the characteristics of a parallelogram, rectangle, and rhombus. That's what this is showing. Rectangles have everything parallelograms have plus their own couple. Rhombuses have everything parallelograms have plus their own couple. But squares is not original. It has everybody in it. It has rhombuses, rectangles, and parallelograms, all of their characteristics. So once we know something is a parallelogram, then we want to test to see if we can go further and prove that it's a rectangle, rhombus, or a square. Okay, so we had 5 ways to prove that a quadrilateral, 4-sided figure is a parallelogram, because notice there's other special quadrilaterals that we're going to learn about in section 8.5. That's these other branches, trapezoids and kites. So once you can prove that a quadrilateral is a parallelogram, then we want to see if we can go further and say if the parallelogram is a rectangle, a rhombus, or a square. It may not be any of those. It may just be a plain old parallelogram. Okay, you may not be able to classify it any further. So let's go to where we're at. So proving that parallelograms are rectangles. It's our next main idea. One way is if you know that one angle of a parallelogram is a right angle, then you can say it's a rectangle. So if you already know it's a parallelogram, either because you proved it was a parallelogram already or they told you in the directions it was a parallelogram, then if the picture shows, oh my gosh, this thing is like spazzing out, hold on. So if I had a, trying to draw a straight line and it is spazzing out. All right, let's see, let's try this again. Okay, if one angle of a parallelogram is a right angle, then it's a rectangle, okay? So if you've got a parallelogram, either in the directions they already told you it's a parallelogram or you proved it was, and they just showed you something like this, where in the parallelogram you have one right angle, that's enough to say it's a rectangle. Because remember, if you know it's a parallelogram and you've got one right angle, well then you know opposite angles are congruent because it's parallelogram, so that's also a right angle. You also know consecutive angles are supplementary, so if that's 90, 180 minus 90 is 90, so then you could prove that those are also 90. So if you know it's a parallelogram, then, and you have one right angle, then you would know all of those will be right angles. Then it's a rectangle, okay? Now again, you can only do this if you already know that these are parallelograms, either because you proved it, you showed it by one of those 5 ways that we talked about yesterday, or talked about last time, or because the directions said, decide if these parallelograms represent rectangle, rhombuses, or squares. So I tell you in the directions it's already a parallelogram, okay? Another way is if the diagonals of a parallelogram are congruent, then you can say it's a rectangle. Now, both of these things are not anything new. Remember the definition of a rectangle says you have 4 right angles. So if they tell you it's a parallelogram and give you one right angle by the reasons we showed before, we could then show that all of these are right angles, which is the definition of a rectangle. This was also one of them. If the diagonals of a parallelogram are congruent, then it's a rectangle. So if you know it's a parallelogram and they draw in the diagonals, and remember how they show you in the diagonals is if they put all of these congruent to each other, that's showing that the diagonals are congruent. So if they show you this and you know it's a parallelogram by the directions or you proved it that way, then you can say it's a rectangle. So both of these are things you kind of already know. this was the diagonals of a parallelogram congruent. If the diagonals of a parallelogram are congruent, that was a rectangle. Okay. Here, one angle of a parallelogram is a right angle, then it's a rectangle, because a rectangle has 4 right angles, and if you just know one angle of a parallelogram is a right angle, you can prove the other 3 are also right angles. Okay. So you would be able to go on and say a parallelogram is a rectangle if the picture looks something like this. And you can pause as you need to if it seems like I'm going too fast. All right, so leave a little space, and now we're on to our next main idea. Proving parallelograms are rhombuses. Okay, so again, the key is that you already know it's a parallelogram. Now you're trying to go further and see if it's a rhombus. First, if one pair of adjacent sides of a parallelogram are congruent, then it's a rhombus. So adjacent sides are sides that are right next to each other. So if you already know this is a parallelogram, and they give you 2 adjacent sides that are congruent to each other, like this, these are adjacent because they're touching, then you would be able to prove that it's a rhombus. Because if it's a parallelogram, like they say it is, opposite sides are congruent. So if that's a single slash, this would be a single slash. These opposite sides would be congruent. So if this is a single slash, this would also be a single slash. So that's a rhombus. Rhombus says it's a quadrilateral with 4 congruent sides. More specifically, it's a parallelogram with 4 congruent sides. Another way to prove that a parallelogram is a rhombus is if the diagonals of the parallelogram bisect the opposite angles, then you can say it's a rhombus. This was one of the characteristics that we talked about the other day. So when the diagonals bisect the opposite angles, that means these 4 little angles are congruent to each other. And if I draw on this diagonal, that means these 4 congruent, or these 4 angles are congruent to each other. So if they show you a picture like this and ask you, is this parallelogram a rectangle, rhombus, or square? You would say it's a rhombus because the diagonals bisect the angles. And remember, that was one of the characteristics of a rhombus, is that the diagonals bisect the angles. And then the last one, if the diagonals of a parallelogram are perpendicular, then it's a rhombus. Well, again, remember that was one of the characteristics of a rhombus, is that if it's a rhombus, then the diagonals are perpendicular to each other. So if you already know it's a parallelogram, and you draw in the diagonals, and they show you that the diagonals are perpendicular to each other, remember how they show you is with the box? Then if it's a parallelogram and the diagonals are perpendicular to each other, then you can say it's a rhombus. And again, that characteristic went with a rhombus. Okay? Then the last one is proving parallelograms are squares. Well, remember, since a square has part of the definition of a rectangle and part of the definition of a rhombus, or the whole definition of a rectangle and the whole definition of a rhombus in its definition, then you would need markings to show that it's both a rectangle and a rhombus. So it will be one of the markings from rectangles and one of the markings from the rhombus we just talked about. Okay. All right, so then have the sub pass out example 3, and you go ahead and glue that in, and then we will talk about that. We'll have to talk about it on the next video though, because I'm running out of time here. So while you're gluing that in, we can get ready and start the next one, okay?